I'm going to talk about prototyping. And what is a prototype? Yes, that's a good question. Because actually, that's what a prototype is, or should be. It should be a good question. This is the Wikipedia, sort of the introductory sentence of Wikipedia. An early sample, a model, a thing to be replicated or learned from. But I think this is like a typical process for coming up with a prototype. I wonder if something, build a prototype to test, and then learn something, right? That's what usually happens. Because, again, a prototype is a question. So the challenge is, how do we make it a sharp one, a good question? That's what I'm trying to figure out today. So going back to those three questions, we have three sort of components of this question. It's uncertainty, it's some sort of experiment, and some sort of learning. And I think you recognize that from a book. This is one of your bingo cards, right? The lean startup method of build, measure, learn. So what is a good prototype then? A good prototype consists of these parts. It leads to a meaningful reduction of uncertainty. And the cost of building the prototype or the experiment is less than the value of learning. Does that make sense, right? So that leads us to three questions we need to ask us when we do our prototype. First of all, what is our uncertainty? How do we find as cheap experiment as possible? And what is the value of the learning that we get back? So let's start with the first one. Uncertainty and measuring. This is a good quote from a good book, How to Measure Anything. A measurement is an observation that quantitatively reduces uncertainty. I'm going to give an example. What is the weight of one coffee bean? Like, just think about like what you think it is. Or actually think about maybe a probable range, like this. A 90% confidence interval means that you're 90% sure that it's in between this range. And a good way to sort of test that is to do the equivalent bet test, which is to say that, okay, let's say I can give you 1,000 euros if the actual measurement is within your range, or we can spin this wheel, and it's a 90% chance of you sort of winning. And if you take sort of the second option here, that feels a little bit more certain, then you have to sort of redo your estimate because it's wrong. Yeah. So let's say I don't know what you thought about this when you heard this question of the coffee beans, but I actually don't have a clue. I drink a lot of coffee, but I'm not a coffee nerd like that. So like, okay, maybe it's like 0.05 grams to 1 gram. So then what happens if we just pick one data point to sort of test that range? Turns out that one bean weighs 0.16 grams. Aha, interesting. A data point, a signal, a learning. That means that our sort of uncertainty was reduced quite significantly, maybe to this range instead. And if we weigh a second bean, okay, it's a little lighter. We keep going like this. 5 is sort of a magic number. Test something 5 times. It's good enough for various reasons. We come up with actually quite a significant reduction of our uncertainty. So this is a way to sort of think about our assumptions and our uncertainties. It's sort of like a range that we need to sort of reduce. We will never have maybe the definitive answer. We will never know for sure. We will only be sort of less unsure. In some cases we will know for sure, but they're rare. Like for instance, you had your example with people actually want to deposit or withdraw their money. We're pretty sure about that. But maybe there are other benefits that we're not that sure about. So going back to this, what is our uncertainty? How do we do a cheap experiment as possible? And what is the value of learning? We talked a little bit about the first one. So how do we work with uncertainties? Well, we call them assumptions. And this is also from the lean startup way of thinking. We can place our assumptions on sort of like a radar or like like an overview of this. If we put these three dimensions to them: uncertainty, the thing we just talked about, the impact it has on us if this assumption is true. Is it a small impact or is it a large impact? And the effort needed to sort of test. So now we will have like a picture of our unknowns, of our uncertainties. What do we need to sort of learn, and which are the most important ones? That would be obvious to us if we had put them like this. That helps us identify the riskiest assumption to test. And just to sort of, if you haven't worked with assumptions before, it's a good way to get started. It's a simple model that we call the risk circle. And it started out like this, basically a 2x2 with 4 fields. On the top you have your customers or your outside. On the bottom you have your inside or your team. And on the one hand you have your ability, and the other one your desire. So that gives you sort of four boxes, with the first one being, do they want it? Does a customer want it? And the second one, do we want to build it? At least that's important, often forgotten. Can we build it, and can they find us? And just to make it even more complicated, we turned it into eight pieces of the cake, or what's it called? Problem solution, team goal, team collaboration, team resources, team skills, usability, and findability. If you sort of use this as like a map, you can fill it out with unknowns or uncertainties that you need to sort of reduce the risk of. And then the next question is, how do we find the cheapest type of experiment? Yeah, that varies depending on sort of where in this product circle the uncertainty belongs. And we can definitely talk about different experiment types in the follow-up session. But here are a few more bingo slides, right? So going back to these again, what is our uncertainty, cheapest possible experiment, and what is the value of learning? We talked about uncertainty and we talked about the experiment, but how do we know the value of the learning? Well, we must find a way to measure what meaningful learning is to us. And for that to happen, we need a direction and a goal, because if we don't have a goal, we will sort of experiment in circles. We will run around like a hen or something, searching for learnings, but we have no direction. And getting closer to that goal, that's progress. So if we learn something that takes us closer to our impact goal, we have meaningful learning. And we've been using what we call an explore card to sort of visualize this for our team, which is split up into three different goals. An impact goal, or this North Star metric, which is sort of our business goal, our customer-centric metric of the value that we create. And our growth bet, which is sort of our current best bet of achieving that goal. It could be if we work on this feature set, or if we work on this traction channel, that helps us achieve this goal. And then at the bottom, our day-to-day experiments that sort of helps us reach the other one, the growth goal. And just to take an example, if you're a car wash service, maybe your impact goal is the number of cars watched. That's like, yeah, you want as many cars watched as possible. And maybe your current growth bet is, we need to work on retention. We need our customers to come back regularly. And how do we do that? Yeah, let's try with an experiment to send out an SMS reminder if people don't book within 2 weeks. So that's an example of how this explore card would look like. But if you can change the impact goal. It depends on sort of where you want to go. Maybe you instead say, okay, we want as many clean cars as possible. So we're not only counting the number of washes, we're also counting the number of customers. Or maybe our promise to our customers is to save time for them when they wash their cars. So maybe we should count the number of minutes saved, or even sort of the number or the amount of money saved in sort of maintaining the car, but because you keep it clean and it doesn't rust and stuff like that. So maybe that's what our impact goal should be. And the thing is that tells us that picking the right impact goal is important, because it sort of frames the challenge for the team. What is the challenge you should solve? Is it sort of saving time for the customer, or is it helping them save money, or is it just to get the number of washes up as possible? It gives you a clear direction. Should we go that direction or in that direction? It's a very, very big difference. And actually, you can even build this in sort of a hierarchy or an impact chart where you have like a top goal for maybe the organization and different sub goals beneath. And you can even add to external stakeholders, and hopefully you can build like a very clear path for someone doing an experiment in a team, understanding the value created by the learnings, and sort of draw the line up into your external stakeholders. So that helps us answer the third question. Are we making sort of meaningful progress by the learning we do? What is the value of our learning? So this is like a simple framework with these 4: learning, understanding, navigation, and assumption. It helps you ask better questions. It helps you get better value out of your prototypes. And it helps you give direction and a sort of purpose for your organization. And that's it. And what I would like to talk about is actually this: how do we ask better questions? How do we use metrics and models to make crisper experiments and better questions? That's it.